Okay, so let me sell you what I'm really here to sell you today, solving absolute value inequalities. So the first inequality we're going to look at is a really simple one. The absolute value of x is less than 1. If we think really hard, we could guess and check and solve this one. So, unless you're told otherwise, we're letting x be a real number, right? So fractions are allowed, decimals. So what kind of values of x would satisfy this inequality? Would negative 10 satisfy it? Let me ask you that. But negative 10 is less than 1. Oh, but yeah, you got to take the absolute value of it. So negative 10 wouldn't satisfy that inequality, would it? Would negative 1.2 satisfy it? No, because the absolute value of negative 1.2 is bigger than 1. What about negative 1 itself? Would the absolute value of negative 1 be less than 1 if you plugged it in? No, because the absolute value of negative 1 is 1. 1 is not less than 1. Now, if there were an or equal to symbol there, a little line there, then it'd be okay. So I gather from what you're telling me, nothing to the left of negative 1 or negative 1 itself will work. So if you're thinking in terms of a number line, whoa, that's a horrible line. If you're thinking in terms, well, 0 does work, yeah. But if you're thinking in terms of a number line, so far what you're telling me is to the left of negative 1, not going to happen, right? And neither negative 1 itself, not going to work, right? What about like negative 1 point, or negative 0.5 rather? Would that work? Is the absolute value of, yeah, sure. If you plug in negative 0.5 for x, plug in the absolute value, you get 0.5, which is less than 1. So that's not a problem. What about 0? Yeah, absolute value of 0, 0, less than 1. What about 0.99? Does that work? Yeah, the absolute value of 0.99 is 0.99, which is less than 1. What about 1 itself? Doesn't work. What about 1.2? Doesn't work. So what you guys are telling me then is that anything to the right of 1 and 1 itself is a no-no. So what about in between negative 1 and 1? Does anything in there work? Yeah, in fact, if we were to graph it on a number line, I think we would shade in between negative 1 and 1. And those are exactly the real values. Any number, any fraction, any decimal between negative 1 and 1 will work. Does that make sense? Okay. So then okay, you can imagine that you're going to get much more difficult inequalities than that. And you're not going to want to guess and check at the answer, are you? So then what's the technique we could use? Well, the negative 1 and 1 turned out to be pretty important, right? In solving this problem, they're the endpoints of the interval of solution. So what you can do is drop the less than and replace it with an equal sign and solve the related equation to get the negative 1 and 1, which I would call those critical values. They're not the answers to the problem, right? They're not even part of the answer in the sense of being a solution, but in the sense of marking our endpoints of our interval, they're part of the answer. So step 1 in solving an absolute value inequality, I would say solve the related equation. So these are general principles, general steps, but within them I'm gonna actually do what I'm telling you with regard to this particular problem. So the related equation is the absolute value of x equals 1. X can only be one of two things. What two things? So x equals negative 1 or x equals positive 1. These guys are called your critical values. So we're going to solve the related equation to get critical values. That's step 1. And just in this particular problem, these are the critical values. Let's call them CVs. CVs for short. Okay, step 2. Let's go ahead and plot the critical values on a number line. So step 2, plot the CVs on a number line. Well, okay, I can do that. So here's my number line. And I will go ahead and put negative 1 here and positive 1 here. And, you know, you could use an open circle for the time being, because we'll pretend like we don't know where we're shading. We'll pretend like we didn't just solve this equation or this inequality by trial and error. So you could use open circles as opposed to parentheses, or just use no mark at all if you prefer. So the next step, the third step then, is to use what I call test values to determine where the solution region is. So let me write that down and I'll explain more as I go. So 3, use test values to determine the solution interval. Now there could be more than one. In certain problems there'll be more than one, so I'll say interval and then I'll put S in parentheses. Use test values to determine the solution intervals. So what do I mean by that? Well, the critical values split up the number line into 3 intervals. So if you go back up here on the graph and look, and I'll put in these vertical lines to kind of really make it clear what the intervals are. There's the interval from negative infinity to negative 1. There's the interval from negative 1 to 1, and the interval from 1 to infinity. And the critical values are borders, they're walls that separate solution intervals from non-solution intervals. And I'll show you a picture of that later on in 2 dimensions. But basically all you have to know to do the method is that as goes the test value, so goes the entire interval. So if you pick a test value from the interval from negative infinity to negative 1, and you plug it in the inequality, and you get a true statement, then you would shade there, because every value from that interval will satisfy the inequality. If you get a false statement, you don't shade there, because every value from that interval will not satisfy the inequality. So that's what we're going to do. So what would be a good test value in this interval from negative infinity to negative 1? We don't get too creative here. We could pick negative 1,000,000 if we wanted to, but negative 2, yeah. You just can't pick the critical value itself. And then the test value in between negative 1 and 1, which one would be easiest to work with? 0. 0. And then you're thinking of the other interval. The interval from 1 to infinity, dose would be easiest to work with. Okay? DOS. What do you guys know about DOS? A lot? Yeah, I used to know all the DOS commands, but you guys are too young to remember those. So what we're going to do with those test values, remember the original inequality is the absolute value of x is less than 1. So we're going to plug those test values into the inequality, see which one or ones give us a true statement, and then shade in the interval from whence it came. I'm trying to bring that word back, whence. I haven't been successful yet. So I'm going to plug in negative 2 here. So the test value, the first one is negative 2. And so I'm going to plug that test value right in here. And you guys tell me, if I take the absolute value of negative 2, do I get, is this a true, I'll put a question mark above the inequality. Is that a true statement? Is the absolute value of negative 2, is that going to be less than 1? No. No. Nope. So we do not shade this interval. Okay, let's just go from left to right. So the next test value, I'm going to pick 0. If I plug 0 in here for x, do I get a true statement? Is the absolute value of 0 less than 1? Question mark. Yes. So yes, I would shade here. In fact, I'll do it right now. I'll shade right there, in between negative 1 and 1. Because that's the interval from whence 0 came. All right, I guess that word will never catch on again. The test value of 2. Now, you guys know it's not going to work, right? But the idea is I'm preparing you for the future. There will be times when you get inequalities where it does work. So this is the entire test value method. So a test value of 2, we plug in a test value of 2 right there, and do we get a true statement? Is the absolute value of 2 less than 1? No! You can yell at it if you want. No way. Okay. So that's the method. Yeah, it's long and boring and kind of lame, but it works. And it works on much more complicated problems than this, which is why I'm showing it to you. So what's your answer then? Well, you know, by the way, that -1 and 1 are not included because it's a strict inequality. So now that you know that, I guess we could have known that before, but the problem is we didn't know which way to shade, so I didn't want to use parentheses. So now that you know that, you could shade appropriately like so with parentheses. Anyway, what's then, from reading from the graph, pretend like you don't already know the answer, reading from the graph, what's the solution interval? Yeah, -1 to 1 is your answer. So what we're saying is all x values in that interval between -1 and 1 satisfy the inequality. So what's really going on here? Maybe we can tell if we graph this thing. Now this is not necessarily the way you're going to solve these problems unless you do it on a graphing calculator sometime. But it is, again, we're preparing you for the future in this class. It's not just about solving a problem you already know how to solve. It's about showing you, because you already know how to solve it, you'll maybe gain some understanding by graphing it in 2 dimensions. That's the idea behind this problem. So here, I'm going to make 2 different graphs. I'm going to set y equal to absolute value of x and y equal to 1, much like I did earlier with the related equation, right? So y equals the absolute value of x. We know this from earlier, that graphs to be that V shape that goes through the origin, like so. So I won't bore you with the details of that again, but it's the same one from earlier, right? So that hasn't changed. It'll always be the same graph. Okay, so that's the graph of y equals the absolute value of x. The graph of y equals 1 hasn't changed either. That's going to be this horizontal line. So y equals 1, y equals absolute value of x. But now you can see what's really happening here. You can see that, okay, remember, it's the inequality we're solving. We want all the x that satisfy this inequality. The absolute value of x is less than 1. You can see that that solution interval from -1 to 1 corresponds with the x-axis from -1 to 1. These are the x values that satisfy it. And now you can really see visually, oh yeah, the graph in green lies below the graph in red, which means, height-wise, right? Which means it's less than. The absolute value of x is less than 1 for those x values in which the graph in green lies below the graph in red. And you can see then the critical values are actually the first coordinates of the intersection points. You can kind of see then where that test value method comes from. There's no way that if you go to the left of -1, there's no way you're going to get an answer. You can really see that in 2 dimensions. There's no way that the graph in green is going to be less than the graph in red if you go past that critical value of -1 to the left or to the right of +1. So anyway, when you up it in 2 dimensions, you really get a feeling, a one-dimensional problem, turn it into a 2-dimensional problem, you really get a feeling for why things work, which is why I'm showing you this as well.